Hey everybody. Last problem in our Thermodynamics and Chemistry 1 worksheet is involving Hess's law. Now, in the video for problem 8, I mentioned that enthalpy is a state function. And so it doesn't matter how we calculate enthalpy or what pathway we take to calculate enthalpy, the enthalpy change is what it is. And so what Hess's law basically does is it gives us a little bit of creativity. It says if I have an unknown reaction, in this case at the top, the reaction in question is the combustion of carbon solid in oxygen gas to make carbon monoxide gas. They'd like us to calculate the enthalpy for that reaction. In the problem, they've given us two additional reactions. The reaction of solid carbon with oxygen gas to provide CO2 gas, and a separate reaction where that CO2 gas is decomposed to give carbon monoxide and oxygen. What I like to do with these is we're basically going to think about how we can manipulate and combine those lower reactions so that they essentially add up to the upper reaction. And the way I like to do it is to kind of dissect apart my reactions, okay? My reactants include carbon, solid, which I only find right here in that first reaction. And so what I would do first is to say, well, what do I have to do to that first reaction to make it match the reaction in question? And the answer is I need to multiply it by 2. So if I take reaction number 1 and multiply it by 2, all right, I'm going to get now 2, I guess I'll keep this in red, 2 solid carbons plus 2 oxygen gases to produce 2 CO2 gases. And my energy change, my enthalpy for that will be twice what is marked here. So the reaction as written was 394 kilojoules of energy released. I'm going to have now negative 788. Okay? That way now my 2 carbons match up. I've taken care of that part. Well, what about my oxygens now? Let's move on to the next bit. I want 1 oxygen here, but I have 2 in, the first red reaction there that I started with. So I need to get rid of 1. That's one problem. I also need to look at my products, right? And my products, if I do this in orange maybe, my carbon monoxide product I see here, and I see that the quantity matches 2 COs on the product side. That's great. So let's just use reaction number 2. Okay, let's see what happens. So reaction number 2 has 2 carbon dioxides to start with in the gas phase to produce 2 carbon monoxide gas phase and an oxygen gas. And the energy here, I didn't change anything in this reaction, so I'm going to keep that positive 283 kilojoules. Now if I add these reactions together, just combine everything, right? I'm going to have 2 carbons and 2 oxygens and 2 carbon dioxides. And on the other side, 2 carbon dioxides, 2 carbon monoxides, oops, I forgot a phase there, sorry, and an oxygen. Okay, and I'll get to my delta H here in just a second. What you can see, I hope, is that I have 2 oxygens on the left and 1 oxygen on the right, so I can cancel that extra one out. I also have 2 carbon dioxides on each side. Those can cancel out. And so what I have left is 2 carbons plus 1 oxygen to produce 2 carbon monoxides. That's the reaction I was trying to build in the first place. That's the one the problem asked me about. So what is its delta H? Well, what did I do to it? I had a negative 788 from the first reaction plus a 283 from the second reaction. I'm just going to add those together. So negative 788 plus 283 gives me negative 505. And my unit, of course, is a kilojoule. That's my answer. When you're doing Hess's law calculations, you can do like we did here. You can multiply one of your reactions by a factor, like we did for reaction 1. You just have to remember to multiply the energy by that same factor. You can also reverse a reaction. If you needed to reverse a reaction, the delta H value will have the opposite sign. So if I had, and I didn't have to here, just to be clear, but if I had to reverse reaction number 2, for instance, I could have written it as 2 COs and an O2 going to 2 CO2s, right? That's backwards from the way it was written. My delta H for that reaction would be a negative 283, right? I didn't multiply by anything, I just reversed it, and so I reversed the sign. So Hess's law lets you do all kinds of neat things like this, depending on what material you're given. In most of the problems you're going to see, you'll be given some reactions that are useful, and you can just use those and figure out how to build them together. It takes a little practice to see it, but as long as you're careful, the details are going to be pretty straightforward, I think. So do some practice. Good luck. Good luck in the chapter overall and with the worksheet, and email me if you have any questions. Take care.